Hi, this is Ms. Sue, and we're working on our homework from page 219, 40 through 30 through 72 even. I'm going to start with 44. Here we're simplifying our fraction. What you should do is always expand out. It's important to note that what you already know about exponents, you need to apply it to this question. Look at it in pieces. Focus on just the m to the fourth. That means I have m times m times m times m. We know that exponents means repeated multiplication. Okay? I know that n to the second means n times n. That is in the numerator of my fraction, so I put my fraction bar here. And in my denominator, I have a 1m and then have a 1n. I'm going to space them out. I'm going to line them up already so that it's clearer for me to see for later. I can also take the 8 and the 40 and also simplify that out. Find the factors that they might have in common. I know that 8 is 8. 40 can be 8 times 5. That's going to help me when I simplify the fraction by getting ones when I start to divide. 8 divided by 8 would give me 1. M and m is 1. N divided by n is 1. These are all ones. So what I have left is I have this m, these n's, and this 5, giving me m to the third, n to the first. If I want to put that, that's optional, over 5. And there's my final answer. Number 52. I have x plus y to the third power over x. They give me that x is 4 and y is negative 3. From there, I'm going to do plug and chug. Just make sure when you chug, it's really a plug and PEMDAS. Okay, so you can kind of think about it as plug and PEMDAS. I'm going to plug the 4 in here and the 4 in here, and then the negative 3 right there. So I have 4 plus negative 3 in a parentheses to the third power over 4. I follow PEMDAS. Do the P first. So I check that. I do negative 3 plus 4, which is positive 1, to the third power over 4. Then I do the exponents, E, so I'm following PEMDAS. 1 to the third power means 1 times 1 times 1. Again, I'm expanding it out. I'm not taking any shortcuts. I want to make sure I get to the answer correctly. 1 times 1 makes 1. I keep the 4 in my denominator, and that's my final answer. I leave it as a fraction. Number 60, I'm simplifying 6b to the 7th times 5b to the 2nd. Again, I'm going to expand out these exponent portions that I know what they mean. I know 6, I'm just going to leave that. B to the 7th means b times b times b times b times b times b times b. I write next to it the 5 because, again, this is a multiplication question. I have one power timesing another power, so what I'm going to get is a lot of powers being multiplied here. That's why it's called a power. B to the second means b times b, so then I'm just going to multiply all this together. I know what 6 times 5 is, so I'm going to get 30. And then if I look at b to the 7th and over here b to the 2nd, that's a total of b to the 9th. And there would be my final answer. Make sure you do not make the mistake of doing this, where most people sometimes will start to write a fraction when the problem never began with a fraction, and then somebody might start to cancel out the b's. It's not a fraction. You're really multiplying them and taking all of them together. Number 64. Here we're going to look at a division one with a fraction. So we're going to simplify 2x squared y to the 5th over 8x cubed y to the 5th. Okay, in this question here, I'm going to expand. I'm going to first expand the 2 and the 8. That will give me 2 in the numerator and then 2 times 4 in my denominator. Then I'm going to expand the x's. Okay. In the numerator, I have x times x. In my denominator, I have x times x times x. Then I'm going to look at the y's. Expand that. Expanding. Expand everything. Always expand. Even if you're not in doubt, just do it, because I don't want you making up rules. Why? 5 of them. So are there 5 of them at the denominator. So here I'm going to start simplifying. 2 divided by 2, 1. 1, x, 1, y, 1, 1, 1, 1. Make your numbers clear. What is left up here? It looks like there's nothing but ones. 1 times 1 times 1 times 1 is just 1. In my denominator, I have a 4 and an x giving me 4x, and there's my final answer. Make sure you keep your fraction bar in your answer when you finish. Number 68, we're moving on to scientific notation. I have 0 point, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 99. This number is clearly a number that is less than 1 or greater than 1. Less than 1. It's a small number, a fraction of it's a fraction. And so I'm going to take the 9 and the 9, 99. I always begin with this number between 1 and 10, so greater than or equal to 1 and less than 10. I'm going to put the decimal right in between the 9 and the 9. Then I'm going to take that to the times it by 10, so I'm taking it to the power of 10, and then I need to figure out what this number is. So there's already a decimal here in the front with the zeros, and I know that I'm moving my 9 between the 9 and the 9. So I'm going to count how far that is apart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I needed to recount that because I was going a little fast. So there's 10. That's going to tell me that this number is going to be a 10. Now, because I was looking at the number in the beginning and I knew it was a small number, that's actually a negative 10. Small numbers will give you a negative exponent. Okay, when I mean small, again, less than 1. Bigger numbers, bigger than 1, like 10 or thousands or hundreds or millions and billions, will give you an exponent that is a positive number instead. Okay, and there's your answer for 69. 8. Here's 70. 3.8012 times 10 to the negative 7. So here I have a scientific that I want to change into a standard. So the standard would be for me to look at the exponent. It tells me it's negative, which is going to tell me the number will be small. If I want my number 3.8122 to get smaller, the decimal should be moving in a certain direction. That direction here will either be left or right, and that will be to the left. Okay, so I'm going to move it to the left, the decimal to the left 7 times. So here's the decimal. It goes 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And there we go. And I'm going to add my zeros. What you're not doing is you're not just counting zeros or just adding zeros because the negative 7 tells you to. It's all about moving the decimal. Here's my final answer with 6 zeros in the front of the 3 before the decimal. And that is clearly a small number, so I was able to check with my exponent and my answer. All right, hope you do well in the other parts of your homework. And if you want to go back and do the odds, that would be even better to get some practice. And the odd answers are in the back of the book, so feel free to do that. I would have liked to assign you all of them, but I did want to keep it down because I know you have other homework. So study hard, and our final is on Friday.